Okie dokes, here we are on page, I believe, is 10. Page 10. So I'll just write that here. Make sure we're on page 10. There it is. Okay. Yesterday we did a line plot about name lengths. Today we already have our question here. That's the first part of the statistical process. It says, what is the typical estimate of the length of our classroom? So now we're talking about people are guessing the length of a classroom. And here we already have the data too. So the first two steps are already done. The first step is to ask the question. The second step is to gather the data. Look at that. It's already done for us. Now, our responsibility will be to organize and then show the data. So let's start organizing it. Okay, here we go. We're going to organize the data using this table. We'll call these estimates. Estimates. These are the room length estimates. And then tally, of course, which is what we did yesterday, tally. And then we'll write down the different numbers we have. We have 13, 14, all the way up, 15, 16, 17, 18, 19, 20, 21. Okay. So for this particular table, we're going to go right from 18, even though yesterday we may have counted up by ones, depending on the class. 25. All right, let's count these numbers up. Let's cross off the numbers that are the same. Okay. And tally them up on the chart. Here we go. Crossing off 13, that's one tally. 13 again is two tallies. Well, these are kind of easier because the numbers are in order. So we just have to make sure we count each number, and that's why we're crossing them off so we don't miss any. Looks like there's 5 15s, and make sure when you do a 5 tally, you cross all 4 of them off. $16 tally. 16 tally. 16 tally. 17 tally. 17 tally. 17 tally. 17 tally. 18 tally. 18 and then 25. Okay. Perfect. So what we're going to do is we're going to make our line plot. Now, when we make our line plot, we'll start at 13 and we'll go up to 25. Now, even though there's no 19 or 20, we're still going to put those on the number line because we want to show what's called a gap, which we talked about yesterday. We want to show that there's no data between 18 and 25. So even though there's no data there, we're still going to write those numbers. And I've got to write these numbers kind of small. Hopefully your paper is a little bit more spread out than mine. This is a little tricky. These double-digit numbers. 25. I can stop here. What I'm going to do to show that I'm stopping here is I'm just going to make a little arrowhead right there. There it is. Okay, I'm going to pause for a moment. My apologies. I had a special guest come in. Special guest. All right. So 13, what we're going to do is for each data point, we're going to put a little X. And we're going to make sure those X's are about the same size, very close to the same size, and they're stacked up about the same amount. We're going to leave a little bit of space in between. 15 is going to be 5, 1, 2, 3, 4, 5. That X is a little bigger than I'd like, so I'm going to erase it. That's what I'm going to do. And make a better X. That one stunk too, so I'm going to erase that one. It's kind of crooked. All right. That's good. All right, 16 is going to be 3. So it should be about almost the same height as 14. 17 is 4. 1, 2, 3, 4. 18 is 2. 1, 2. There's nothing for 19, nothing for 20. We still want to show that there's a gap there, and there's one out here for 25. So that one's pretty far out there. That might affect something later. All right, it's kind of what we talked about before with the temperature, maybe. What should we call this? I guess we could use this as a title, I guess. We might say like room length estimates. Okay, so now we've done the third step. We've organized the data and we've shown the data. Now we move on to the last step, step 4, and that's to answer the question. So when you go to the next page, page 11, make sure to turn it so you can see both page 10 and page 11, so you can see the graph we just made and page 11 at the same time. And that's going to help you answer the next questions, because I might have to be popping back and forth here. So I'm going to write a couple things down just to help me so I don't have to pop back and forth on the screen too much. So give me a moment here. All right, so I'll get you set up, and then we will continue finding our answer for the graph we just made. Okay, here we go. Page 11. Now, our question, we're just going to write, we don't have to write the whole question again. It was about room length. Okay. So the first thing we're going to do is find the measures of center. These are the two main measures of center we're going to use. The mode is usually saved for questions that are asking like what's the most popular of something, or what is the most common of something. We're looking for what's typical, what's average. So we're going to either use mean or median to find the middle. Remember, mean is kind of like an average there. And so what we're going to do is we're going to find the sum, which is adding up all the data, the sum of the data divided by the number of data. Okay, let's add that data up. And we're going to kind of group the numbers together so we don't have to show 20 different numbers here. So we have 2 13s. Uh-oh. 3 was a little weird. Okay, 2 13s plus 14 times 3. That's a plus sign, by the way. Plus 15 times 5. Plus 16 times 3. Hopefully you're writing a little bit smaller than me, because I'm not sure if I'm going to be able to fit this in this rectangle, but that's okay. 17 times 4. 18 times 2. And that lonely 25 outside the rectangle. And we're going to divide all of this. Here we go. Long line here. This is the division bar. We're going to divide the whole thing by how much data we had. I believe it was 20. Let's check that. Whoop. So we have 1, 2, 3, 4, 5. 5 times 4 is 20. I'm just going to check to make sure we graphed it all. 1, 2, 3, 4. That's 10. That's 13, 17, 19, 20. Perfect. Okay, we're going to divide the whole thing by 20. So at this point with your calculator, and I'm going to do it too, just to give you some time to do it, I want you to add up all of the numbers on top in the numerator. That's going to tell us the total number of feet that everyone guessed to make their estimate. 14 times 3. So I'm just putting this all in the calculator. Be sure you're pressing the correct buttons, because one missed number will throw it all off. Times 2 is 25. Okay. So I found it. Well, okay, that's going to be nice. So when I added those all up, see if you got the same thing. I got 320. And we're going to divide that whole thing by 20. Okay. All right. Let's do it. 320 divided by 20. Got 16. It's going to be 16. I believe it was feet. Let me just double check that. No, it's in meters. It's in meters. So it's going to be meters. So the average person, or the average guess in the middle, right in the middle, was about 16. Okay, there were some greater, there were some less. 16 is our mean, is our average. Now the median is going to find the middle number. The middle. Okay, so what we have to do is we have to line up the numbers from least to greatest, and then we will find the middle by crossing them out until we get the middle 2 or the middle 1. Now, as we're doing this, let's think if we need to, we're going to have one number in the middle or two. Think about that as we're lining up these numbers. That's 15. 15. 16s, 3 16s. Oh no, that 25 might be outside the rectangle again. Again, hopefully you're writing smaller than me, a little smaller. Oh, and the 18s. Oh no. Okay. Now, let's think about this. We have 20 data points, and that 20 is, you can see that 20 here. We counted them on the previous page. We have 20 pieces of data. So that means if we have an even number of numbers, like if we had, I think we did this yesterday. 1, 2, 3, 4. If we have an even number, what's the middle? The middle is going to be halfway between the middle two numbers, because there is no one middle number when you have an even number. So in this case, the median would be 2.5. We're going to have to find the middle number for this set of data by looking at the middle two and finding what's halfway in between. So what we're going to do is we're going to cross off the least and greatest until we get to the middle two. Because we have an even number, we're not going to have a middle one. We're going to have a middle two. I have a feeling of what it's going to be, but I don't know if that feeling is accurate. Let's see. Oh, look at this. Look at that. We have a middle two. It's 15 and 16. So what I like to do is circle the middle two, put a line right through it. And then I like to think, well, what's the exact middle of 15 and 16? If you don't know, this is a little helpful hint. You can add them up. So we'll do 15 plus 16 and then divide by 2. That will tell you the middle of those two numbers. So 15 plus 16 is 31, divided by 2 is 15.5, which I guess makes sense. Halfway between 15 and 16 is 15.5 meters. Okay. So those are the measures of center. Now we're going to look at the mode, which again is the most popular piece of data. And we're going to think which number comes up the most often. Well, if you look up here in the mean, we had 2 3s, 3 14s, 5 15s, 3 16s, 4 17s, 2 18s, and a 25. So it looks like we had the most 15s. If we look back at our graph, same thing. 15 is the highest. That's called the mode. So the mode is 15 meters. It came up the most. Okay. So then we got to think which measure of center would we use. We're not looking for like the most popular one or the one that came up the most. That's not what the question's asking. It's asking for like what's the middle, what's the typical, what's the average. So are we going to use mean or median? Okay, well, we could answer that question if we knew if there was an outlier or not. Now, if we look back at our graph, that 25 is pretty far away. Okay, so we're going to call that 25. You can even jot it down here with a little arrow.
Cameron Kiani, please go to the front desk.
Outlier.
Cameron Kiani to the front desk.
Okay, so we have a little outlier here. Name's 25. That outlier tells us that 25 is kind of pulling the mean up. It's pulling this number up a little bit more. So because we have an outlier, we're going to use the median. And we saw that when we worked with that temperature problem we did right at the beginning. Because that 93 degrees pulled the mean up. Because that 93 degrees was all way hotter than any of the other temperatures. We use the median. Now, there's a mathematical way to find the outliers. We're not going to do that this year, so if there is an outlier, I will just tell you if there is one. We use the median because there is an outlier. Nice. Okay. Let's talk about range. The range helps us find the spread. So what's the range? The range is the greatest number minus the least. That tells us, again, how spread out it is. The greater the range is, the more spread out it is. So the greatest number is 25, and the least is 13. So we're going to do 25 minus 13, which is 12 meters is the range. That's the range of guesses from the greatest to the least. And that will show, again, the spread. So the range and the spread kind of go together a little bit. All right, the last thing we're going to talk about is the shape. So I'm going to have to kind of go a little bit back and forth to talk about the shape. You may already have a good idea of what the shape might be. Let's talk about that. So the peak. The peak, again, is like a mountain peak. We got a mountain. That's a mountain, believe it or not. And there's the snow. So the peak is the top of the mountain. Okay? Very top of the mountain. Kind of looks like a pencil in a way. All right, so then we're going to look for the very top of the line plot. It's going to be at 15. So 15 is the peak. Peak is 15 what? 15 meters. Well, I'll just put 15, actually. We'll just put 15. Okay, cluster. That's when there's like a lot of data, like a cluster of granola. It's like packed in a lot. It's where there's a lot of data in a small space. So I'm looking at the data. There's a lot of data, and I wouldn't circle this. Don't circle this on your paper. But there's a lot of data like right here. So from 15 to 17, there is more than half the data is between those two numbers. So that's called a cluster. It's when there's a lot of data in a small space. So the cluster is from 15 to 17. All right, let's talk about gaps. Well, there's a pretty clear gap here. And that's between 18 and 25. You see there's no data here. That shows that there's a gap. So the gap is between 18 and 25. There's nothing between those 2 points. So the gap is between, the gap's like a space. So double check that. Is it 18? 18 to 25. Perfect. Okay, lastly, symmetry. It's almost symmetric. It's close, but not really. So like if we moved around, like this part of it kind of looks symmetric. This outlier is really far away. So if I cut this in half, it's not necessarily the same on both sides. So we'll say that there's no symmetry. Okay, so to answer our question, we still have to answer our question. Question was, what was the typical estimate for the length of the room? Okay, what was the typical estimate for the length of the room? So we said that the measure of center, the best one to use, would be the median. So our answer, I'll highlight it to make it stand out a little bit more. Our answer is going to be 15 and a half. This is the answer to our question. And we used all of this data to help us find that would be the best measure of the center, of being typical. Okie dokes. Well, I hope you're having a great day. Make sure to like and subscribe to my YouTube channel if you so choose. And I hope to see you soon. And again, I think I said it already, but have a great day. Okay. Bye-bye.